Welcome to EDU World Space.
So you have this function. You have x as a function of y. X is equal to y plus y cubed. So if we draw that here with this one as the x-axis and that one as the y, we're gonna have a function that looks sort of like that. This is the graph, the curve of x is equal to y plus y cubed. And you want to compute what is the area of well, what happens if we rotate um, this piece of the curve from 0 up to 1. Well, first about the y about the x-axis. So if we rotate that about the x-axis, we're gonna have some shape like this. Rotating that around there, sort of like this cup. We rotate about the x-axis, and well, we will also like to compute the area of that same curve, but now rotating about the y-axis. So the curve something like this, and if we rotate now that same interval from 0, that same piece from 0 to 1 is y-x, and then about the y-axis, we're gonna obtain like this shape. So well, to compute these areas, the area here, also here, here is we have x as a function of y, so that this area is gonna be the integral from 0 up to 1 of f of y times the s of the s dy. This is the differential of length of the s dy of the curve, that is the following f of y. Oh, we have 2 pi that, because when we rotate, and it's like rotating like the piece of a cylinder, and then times the length here, so that would be 1 plus f prime of y, if relative with respect to y, that squared times dy. And then for this one, since all the length here is, the distance is gonna be y at each point, so the area for this one would be the integral from 0 up to 1 to pi y times that is dy, that this is equal to 1 plus the derivative of the function squared, square root of 1 plus the derivative of the function squared dy. So so you have that, and then for this function, if this is f of y, x is equal to f of y, f prime is gonna be equal to the derivative of this is just 1 plus 3y squared, so that this integral over here would be the integral from 0 up to 1 to pi y, and then times the square root 1 plus 1 plus 3y squared, and then we have to square that, so that times 3y, and this this other one, this other area will be the integral from 0 up to 1 of 2 pi times the function that is y plus y cubed, 2 pi times y plus y cubed times square root of 1 plus 3y squared, and then that squared y, and when we pull out our favorite calculator, this number here, let's call this one 1. 1 is approximately 8.5302, and if we call this one 2, this integral 2, so 2 is approximately 13.5134. So those are the areas of these two surfaces of revolution about the x-axis. So this one is surface of revolution about the x-axis, and this one is surface of revolution about the y-axis.